All right, welcome back. So let's talk about the properties of minerals. I changed the section name. Let's talk about the properties of minerals because that's what's going to help us identify the different minerals. Remember that a mineral is defined as something that's naturally occurring, it's solid, it's inorganic, has an internal crystalline structure at the atomic level, and a specific chemical composition and properties. And so we're going to talk about those properties. The properties are controlled again by the chemical composition of the mineral, what it's made of, and the crystalline structure. So there's a handful of these different properties we look at that each different mineral has, and this is how we identify them. Excuse me. So the first property we look at is something called luster. A luster, when we're looking at a mineral, is how light is reflected from the surface of the mineral. And we break it down into two groups. Metallic, which are reflective, they reflect light. They're kind of like, shiny metal. And then non-metallic. That's how we break it down. Now, there are some non-metallic lusters. There are some minerals that have non-metallic luster that reflect light, but they don't reflect it like kind of in a metallic way. They reflect it maybe like glassy way. So anyway, the first thing we look at when minerals and we're trying to identify it is luster. How does the light reflect off the surface? Either is it metallic or non-metallic? We can get into the subcategories, but those are the two broad ones we focus on. Next is cleavage. Cleavage is the ability of a mineral to break along preferred planes. So how does it break? So if I took a hammer and I smack this thing, how does it break? So if something has cleavage, it breaks with these nice flat planes. We say cleavage has different amounts of direction. For instance, one direction of cleavage, these minerals will break into these flat sheets. Two directions of cleavage, there's two sides that would break flat. Three directions of cleavage, three sides would break flat if I smacked it and broke it. Here are some different types of cleavage. Again, this is not how the mineral grows. It's how the mineral breaks. That's a big difference. Because, for instance, a quartz crystal, I don't know if I have one handy real quick. Well, hold on. One second. Be right back. Alright, I'm back. So, for instance, I don't know how well you can see this because of the bright light. A quartz crystal. So, these flat sides are how... Oh, that works. You know what? Let me make me bigger so I can see what I'm doing. Yay! Look at that. Hello. So, these quartz crystals, these flat sides, that's how they grow. That's not how they break. And that's what cleavage is. So, when quartz breaks, it breaks off into kind of almost this nothing pattern. It does not have cleavage. So anyway, what I'm trying to say is you got to be careful when looking at cleavage. It's very useful for a veteran geologist, but for someone new to geology, it's kind of hard to wrap your brains around cleavage. But just know it's if a mineral breaks into nice flat sides. That's what cleavage is. Again, there's all these different types of cleavage. If you take a mineral and you smack it with a hammer and it just doesn't break with any flat sides, it just kind of crumbles and has all these non-flat sides, well then that's known as fracture. So that's when a mineral breaks with no kind of planar pattern, no flat pattern. A number of minerals do that. A lot of minerals do that. Another property we can look at of a mineral is something called hardness. And we look at hardness based on something called the Mohs hardness scale. Hardness is the ability of a mineral to resist scratching or to scratch something else. It's not how strong the material is. So looking at the Mohs hardness scale, this is just a reference scale from 1 to 10. Talc on this scale is the softest mineral. Diamond is the hardest mineral. Now, a diamond has a hardness of 10 on the Mohs hardness scale. It is the hardest mineral that we know of. A diamond can scratch anything, right? So if you have a big diamond ring, you can scratch anything. You could go up to glass, you can go up to anything and scratch it. Another fun fact about diamonds, if you do that, if for some reason you're angry at someone and you have a diamond ring and you try to scratch their windshield and it doesn't scratch the windshield, you don't have a diamond. So diamond is the hardest mineral, but it's the ability to resist scratching or scratch something else. It's not how strong it is. If I took a diamond and I smacked it with a hammer, it would crumble. All right? If I took any of these things and smacked them with a hammer, they would crumble. So it's not how strong the material is, it just has to deal with scratching. And then oftentimes for a reference, we use glass as a reference. Glass, which is made up of minerals, silica, and a number of other things, has a hardness of around 5.5 on the scale. So if a mineral has a hardness below 5.5, it cannot scratch glass, no matter how hard I try. All right, no matter how hard I try. If I take any of these minerals, calcite, fluorite, apatite, gypsum, talc, and a number of other ones, this is just a handful of minerals, and no matter how hard I push on that glass, it won't scratch it. But if I take any mineral that is harder than glass on this scale, 5.5 or more, things like feldspar, quartz, topaz, corundum, which is ruby, and or diamond, I can easily scratch glass. So oftentimes we carry around a little piece of glass, and if we find a mineral, we'll test it and try and scratch glass, and really quick we can kind of assess its hardness relatively. But there's other tools you can do, you can use to assess hardness. Again, it's all about scratching. So I have this like little pick set, and each side has a different hardness. This has a hardness of 7. This has a hardness of 6. So I can scratch things and see it's the mineral's ability to scratch or be scratched. So again, that's the little glass plate that we often carry around in our little toolkits as geologists when we're trying to assess this particular property of a mineral, which is a hardness. Another property is its streak. The streak of a mineral is the color of the powder that's left behind when on a little porcelain plate called a streak plate, when the mineral is kind of scraped across it. When you take a mineral and you kind of color on this particular type of glass plate called a porcelain streak plate, it leaves behind a little bit of dust. And the color of that dust is what's known as the streak. So what's interesting is that, let's say we have this mineral here, which one of the easier ones to identify, this is something called hematite. When I kind of color back and forth on this white streak plate, it leaves this nice reddish brown streak. That's very indicative of what hematite does. But then I have this other mineral. It's like kind of silvery, but yet when I streak it here, it's also reddish brown. What the hell? Now, there are a number of other minerals that have a reddish brown streak, but this is just a very interesting case. This too is the mineral hematite. These are both the same thing. They look very different, all right? But looks can be deceiving, all right? The look, especially the color of a mineral, can be very deceiving. These other tests are very important to do. Looking at the cleavage, looking at the hardness, looking at the streak. It's kind of tricky. So anyway, that's what streak is. Speaking of color, the color is typically the least useful when trying to identify many varieties of common minerals. There are some minerals that have distinct colors, and that is helpful. But in general, it'll mess you up every time. Oh, it's this color, therefore it's this. Again, there's a handful of minerals that you can do that for, but oftentimes, it's usually not the best bet. The reason being, these are all the same minerals. These are all a mineral called fluorite, but yet we have this kind of pale blue, deep purple, light purple, yellow, clear. Or things like tourmaline. I mean, the same thing is all different colors all throughout it. So color can be kind of tricky. These are, I believe, chunks of fluorite. Whenever you see, oftentimes, like crystals like this that they're selling, this is just a side note, that's not how those were grown. Someone just cut and polished them to make them look like a crystal shape. In nature, they don't look like that. But anyway, I digress. But you can see how they're different colors, and so just because it's a particular color doesn't necessarily mean it's a particular mineral. You just have to be careful, right? You just have to be careful. Look at hematite. Fluorescence. Some minerals fluoresce, meaning they glow when exposed to ultraviolet light, UV light, also like a black light. One of those little lights that you look at to find scorpions at night, that's a black light or a UV light. Some, not all, very few minerals are fluorescent. So they look kind of just like normal everyday objects. But when you shine a black light, a UV light on them, they glow these fantastic colors. So some minerals have this property. Other properties include something called birefringence. So if a mineral is birefringent, when you look through it, if you're able to look through it and look at words, it looks like it's kind of doubled. Some minerals are magnetic. They're attracted to a magnet. Go figure. Some minerals react with acid. You drop a little bit of very diluted acid onto a mineral, and if it reacts, you'll see a little bubbling and fizzing. We use weak acid because if we use very, very strong acid, it would dissolve anything. But if we use very, very weak acid, there's only a few minerals that will react to acid. And you can tell right away, oh yeah, this is this mineral. Calcite is one of those. And then probably one of my favorite properties is taste. Yes, a few minerals have a very distinctive taste. Some are better than others, let's say. Yeah, there's been many a times I've been out, in nature and I'm stuck and I don't have my stuff. And I'm like, oh, well, let me just taste it real quick. Oh yeah, it's this. One of my favorite examples, I was in Death Valley at the lowest part. It's called Badwater Basin, and there's a sign and it said the ground is salt, halite, which is a mineral. And I was like, I don't know, and you can't break and pick it up. So there's only one option. That was for me to get down on the ground and just take a little taste, and yep, sure was salty. I've done it thousands of times. That was just one of my favorite ones. People watching and taking pictures of me. Somewhere out in this world, there's a number of people that took pictures of me looking at the ground like, what is this crazy person doing? I'm a scientist. What are you going to do? All right. Any case, the reason I went over that, we may identify some minerals in lab. Still trying to figure that out, but I wanted to go over these properties and characteristics just in case you see them again. So we're going to go ahead and pause there. When we come back, we're going to talk about our first type of rock, and that's igneous rocks. See you back here in just a minute.